In 6.1, we're going to look at finding the area between curves. Now this kind of picks up from where Calc 1 left off on area under curves. Remember, if you have an integral like this, a definite integral from a to b of f of x dx, if f of x is a positive function from a to b, then what you get is the area under here. And if it's not positive everywhere, let's say this is A and this is B, what you get is the area under here, and then you subtract this area over here. But the stuff you did in Calc 1, all of that dealt with just one curve and the x-axis for your other boundary. What we're going to look at in this case is area between two curves. So let's say you want to find the area between the curves y equals f of x and y equals g of x. And we're going to assume for starters that they don't cross each other. And you've got f of x on top and then g of x on bottom, like this. And let's say this is A and this is B. Well, what we're trying to find, let me change this to a slightly lighter color. What we want to find is the area underneath, or in between here. So all this area here. What we will do is we'll take this area and we'll split it up into a bunch of rectangles. I'm going to do that, because we can split it up like this and have a bunch of rectangles and use those rectangles to approximate it. And notice the top of the rectangle is on F and the bottom of the rectangle is on G. So instead of drawing all those in, let's just draw one and draw it really nicely. I can put one little rectangle here. Now if we look at this rectangle, its height I'm going to call this point just x. Its height is going to be equal to f of x minus g of x, so that's top minus bottom, and its width is just that tiny little change in x from one side of the rectangle to the other. So that width is dx. So if you want the area of that slice, it's just going to be the height times the width. And that's where this formula over here comes from. The area is integral of from a to b of f of x minus g of x times dx. And you know, it's worth labeling here. This is the height of the rectangle, and dx is the width. So let's do an example. Down here, this says find the area of the region bounded by y equals square root of x, y equals x squared plus 1, x equals 0, and x equals 1. So I've got all that stuff drawn in here. Let's color it in. Here's the area. Unfortunately, this program I use doesn't have a fill tool, so I have to just color it in manually. All right, so a rectangle would look like this. I'm just going to draw it somewhere in here. And so the parabola, this one's on top, and this one's on bottom. So my area is going to be integral from 0 to 1 of x squared plus 1 minus square root of x dx. And let's work this out. This integral isn't going to be too bad. Let's see, that becomes integrate x squared, you get 1/3 x cubed. Integrate 1, you get x. If you integrate, let's see, that's x to the 1/2. When you integrate that, you get x to the 3/2 with the 2/3 on the front. Then you're just going from 0 to 1. All right, this is nice because we don't really have to plug the 0 in because this is just going to give us 0. But if we plug in the 1, we get 1/3 times 1 plus 1 minus 2/3. And let's see, what is that? 1 minus 2/3 plus, that's just 2/3. All right, so the area inside of there is 2/3. Let's look at this example. We're supposed to find the area of the region bounded by these two parabolas, x equals -1 and x equals 1. All right, so let's look at it first. This parabola is 4 minus x squared. So that's my top. The other one's the bottom. And we're supposed to just go from -1 to 1. So I'm going to come over here and draw those lines in. Here's -1. Wait, is that right? Actually, no. This is -1 here. Got to be careful. That's the, since this is 2, yeah, every 2 ticks is 1 here. So we're supposed to be finding the area inside of here. All right. So that's going to be the integral from -1 to 1 of the top minus the bottom. And before I actually do the integral, let's I want to do two things to this. First, I can combine those together to get 4 minus 3x squared from -1 to 1. And another thing I can do here is symmetry. This side over here and this side over here are exactly the same size. So I can use symmetry to make my integral a little bit easier. Instead of integrating from -1 to 1, I'm going to integrate from 0 to 1. And let's see, and that's going to get us the area of half of it, and then I have to double it in order to get the full area. And this shouldn't be a bad integral to do. Let's see, we've got a 2 on the front, 4 gives me 4x, 3x squared gives me minus x cubed. We're going from 0 to 1. So when you plug in the 1, you just get 4 minus 1. Plug in the 0, you get 0. So this just winds up being 6. And that's our answer. Now, on a problem like this, I like to do a bit of a, just sort of a check to see if this looks reasonable. 6 is supposed to be the area inside of here. And let's count the squares. Each one of those squares, notice in a like 1 by 1 bit, each one of those squares is 1/4. So this means that there are 24 squares that are full. And so obviously some of these squares are partially filled in. So let's just see if it looks like 24 is reasonable for the area here. Let's see. I'm going to count the ones that are mostly full. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. And there's a little bit more, but some of those squares that we counted weren't full. So yeah, it looks correct. All right, let's do this problem. Find the area enclosed by y equals x squared and y equals x to the fourth. All right, so that's already graphed out for us here, and we can use the same sort of symmetry trick here. So tell you what, let's do. Let's just find the area. Oh, that's big. Let's just find the area inside of here. Like, I guess I should shade both of them since it's asking for the whole thing. But I'm just going to set it up as the area of one of these things and double it. Let's see. X squared is the one that's on top, and x to the fourth is on bottom. So when we do this, we're going to get, let's see, integral of x squared minus x to the 4. And we're going from, let's go from 0 to 1 and double it. All right, when we do that, I've got a 2 on front, and then 1/3 x cubed minus 1/5 x to the 5th from 0 to 1. All right, plug in my 1, I get 1/3 minus 1/5. And let's see, what is that? 1/3 is 5/15. 1/5 is 3/15. So this looks like 4/15. All right, and that's it. So far, I didn't draw my rectangles in on these. Maybe it's worth doing that again. Because on this, a rectangle is like that. Its height is from the top. You know, if I were to label this point, this would be the point x, x squared. Point down here would be x, x to the 4th. And the width would be a tiny change in x. All right, so next up we'll talk about horizontal slicing.